Morning, everyone. Thanks for coming. I'm going to take 25 minutes of your time today, so hopefully it's going to be useful. I'm going to make my best so that you will learn something today. My name is Dmitry Shevrin. I work as a senior solution architect for Spectro Cloud. It's been 3 years now I'm with the company. Prior to that, I was working for Rancher SUSE, and prior to that, spent some years at Red Hat. So altogether, it's been 15 years I've been doing infrastructure, and most of them I've been doing Kubernetes. Throughout my career, I've been involved in a number of projects. Some of them were with manufacturing, and today I wanted to talk to you and to tell you my experience and our experience with different projects in manufacturing, how to avoid common pitfalls, how to be efficient, and especially how to make deployments on scale with hundreds and thousands of devices and factories across the world. First of all, we are going to cover what is it driving Kubernetes at the edge, why we want to have Kubernetes at the edge. Again, it's Kubernetes at the edge day, so I'm hoping most of you have some reasons to have Kubernetes. Then we'll see what are the challenges for deploying edge in factories, in manufacturing. There are some challenges specific to manufacturing, there are some challenges generic across edge. Then I'm going to talk about the typical journey we are seeing, so what are the common pitfalls, how to avoid them, how to be efficient, and then I'm going to give you some, let's say, shortcuts or keys to success so that you'd be able to deploy Kubernetes on the edge at scale anywhere you want. I'm going also to provide a couple of next steps, direction, where to go, so that you will bring some value from the presence today. So let's start with why do we want to have Kubernetes at the edge, right? So there are multiple reasons. Most of them obviously are business reasons, so there is a set of applications that require to work at the edge. Now, if you can live without Kubernetes on the edge, by all means do. What we are seeing is, in our experience, is that sometimes you just don't have a choice, right? So you may want to start easy, but there will be vendors who are just delivering their software in Helm charts. It's basically whether you want it or not, you have to install it. Now, IT-OT convergence is happening everywhere now. So operational technology, information technology merge, so that it's been driven by business, and therefore you have no choice really to deploy Kubernetes and make it working at scale. Now, with AI, again, having its hype and deploying everywhere, normally AI requires Kubernetes to be deployed across the whole estate, and it's just like a prerequisite, right? So it's pretty much standard to host applications. So therefore, yeah, we are seeing it's a necessity. Let's look at challenges, right? So what is it that is stopping from successful deployment across the whole estate? Some of them are applicable for the whole edge deployment. So let's say bad intermittent connectivity. That's something where you wouldn't have stable data center fiber. There will be Wi-Fi, there will be 4G, 5G, doesn't matter. Sometimes it disappears. So the whole system must accommodate for that. Connection may disappear for minutes, sometimes for hours, and it comes back. Bandwidth can be quite small, latency can be big. So yeah, that's creating some challenges for etcd and deployment Kubernetes at the edge in general. Now, locations pretty much can be anywhere, right? So what we are seeing within manufacturing, the specifics is that some fabrics are located overseas, some fabrics are located far away from headquarters. It's a factory, right? So sometimes it's just hot. I mean, it's physically hot, so devices must tolerate the physical conditions and environmental conditions they're not as, easy as air-conditioned office. Now, what we are seeing is that sometimes there is a deployment starts with 1-2 devices, but eventually for big manufacturing, there will be hundreds, thousands, and sometimes tens of thousands of devices deployed across the globe. So the location would be huge. Now, think of it. If it's a big number of locations, if a big number of devices, statistically speaking, every device will break. One device will break every week, right? Just because it's like, if you have 1% of failed devices, this is not going to work for like all the devices are not going to work forever, right? There will always be breakages. we already briefly spoke, and I'm sure most of you familiar, yeah, there is no Kubernetes expertise on site. No, there is no Kubernetes guys. There are hardly any IT guys. So they will probably be able, at most, just plug the cable, and that's it. So they won't be able to do any kubectl debugging, any kubeconfig file. No, that's not non-existent. So that's making it difficult in case of problems, right? No one is going to fix the problem on site. What we are seeing further challenges is that all the mandatory legal data requirements, they mandate keeping data locally. So even though the company can just send logs or information somewhere to a central location, due to legal requirements, that can't be happening. So therefore, it's now your problem how to process information on the edge, how to process information within factory, where you might not have a lot of computing resources. One of the solutions we've seen in the past was just pushing data to the cloud from the edge, processing there, sending it back. Well, it's not quite working either, just because, well, first, you see point one, the connectivity is intermittent. You might just not have enough bandwidth to send information to the cloud. Second, it's becoming expensive because of all the ingress costs. It's just not sustainable. The last challenge is that we can't afford any downtime, because if sometimes, with some of the servers you can just redirect, do traffic, do some sort of magic within a factory and manufacturing. Whenever a device stops, if there is critical information depending on that, that's just huge financial losses for the company. It costs hundreds of thousands of dollars or pounds or euros or even millions. So we can't zero downtime. What we found that is the typical journey is that, first of all, many deployments just start manually. So you deploy some distribution, you do it manually, you just write a set of scripts, I don't know, bash scripts, whatever, Ansible, Terraform, doesn't matter. You just do some sort of manual deployment, you play a little bit with Kubernetes tools, then you proceed to automation, right? So that's what I'm showing you here is an example of a typical journey in manufacturing where all the steps we were kind of learned the hard way, as in it takes pain, it takes resources, it takes time, and sometimes it takes money for the companies. The second step would be some automation, right? So you would start deploying some sort of infrastructure as code solution, then you would do some orchestration, yeah? So I'm trying to make this talk generic, so I'm not talking about specific tools. You can use any tools, but the generic learning curve is going through these steps, right? At some point, you realize that it's going to be better to do an immutable deployment, simply because, well, it helps going through certifications, it helps doing the full-blown deployment and have not snowflakes, but have elements that you could easily replace, right? The last step would be remote access, because sometimes, like I said, factories are far away. You can't really go there. You can't do even SSH. They run in internal networks, so therefore you need to solve this problem, right? So this is what we've seen, a typical journey that is taking months, sometimes years. Now, I'm talking about problems so far, right? But I don't want to be overly negative. I wanted to approach, so what is it that we are trying to say here, right? So what I talked about challenges, I also want to talk about how to solve these challenges. Now, when I say challenges, it doesn't mean it's a showstopper. It still works, right? Except that it's blocking the speed. And what we are seeing is that when edge solutions are going through their own deployment, through their own way and speed, you just can't be doing the deployments using non-efficient ways. You must follow some rules so that you'll be able to get velocity, the deployment velocity, right? So if you're doing manual deployment, if you're doing something for one box or one factory, yeah, it's fine. You can do pretty much everything you want. But as soon as the number of devices grows and you have to manage all the devices in an efficient way, the complexity of configuring the Kubernetes and patching is from day 0 to day 2. So upgrades, applications, that kills the speed, right? And this is what we need for production. For production needs scale needs speed. This is what we are looking at for. Now, I'm going to offer you here 5, let's say, shortcuts, so that you would avoid all the pitfalls and you wouldn't go through that, Learning curve, right? So the first one, I'm not sure if everyone was here listened to Saad's talk, but eliminate snowflakes, right? That's going to be unique devices. That's not going to allow you to scale, right? I'm going to go into each one of these elements right now and give you practical advices that we learned from real deployments in real world. Second is to declare everything so that, approach infrastructure as code, apply it to everything, apply it to operating system from scratch, from starting the device up the stack through all the applications. Third one is security. It's never going anywhere, and what we are seeing is that the devices redistributed across factories, they sometimes and quite often contain secret information, and they contain private information that can't be stolen. Fourth one is the auto-healing. That means that due to absence of staff at remote locations, we want these devices to recover as soon as they can, to recover automatically without human intervention. And the last one is deployment, right? So when we say zero-touch provisioning, which means the device will be just plugged in and it should start, it should get the IP address, it should make its way, configure the cluster, and then be available for you without any human intervention. So let's look at these shortcuts one by one. Snowflakes is something that you would configure manually, right? That you would leave there, you wouldn't configure that on scale. So it's something that maybe you, maybe someone else, maybe your predecessor configured. So some sort of modification of a cluster, I don't know, manual patch, manual operating system. This is killing speed. So the approach of infrastructure as code, if you're familiar with Ansible, Puppet Chef, Terraform, made it efficient for simple deployment of Linux servers. The same principle should be applied to Kubernetes as soon as you can, right? Now, there is no magic bullet, so if you already deployed some clusters and if you have snowflakes, well, you need to bite the bullet, you need to just create a cluster template, doesn't really matter from what, but you need to gradually redeploy these clusters. Yes, it's going to be painful. However, once your whole estate is built from a template or a set of templates, you can be confident that you can grow, you wouldn't see any bottlenecks, you would be efficient in terms of growth of number of devices. When I say manage components declaratively, I mean describe them so that prepare a set of constructs so you will be able to redeploy the whole cluster. Again, deploying normally clusters is not complicated, right? So deploying clusters is fine. It's just further down the line. It's when you'll need to upgrade clusters, when you'll need to upgrade applications, when you need to maintain versioning of these applications. At some point, security may or legal may add some requirements. You may be forced to add some applications. So what this brings you is an opportunity to add new element in an efficient way, right? So all of your clusters are deployed from some sort of template, and you manage these templates. What declarative state allows you to do is to do an extension and to maintain the whole deployment of the whole set of clusters in the whole world across the whole estate in an identical way. That permits you to be efficient. That permits you to get into production and deploy clusters at scale. Security. As device contain private information, you must prepare. So what happens if the device is stolen, right? Can I ask you by a show of hands who just has today encryption of their devices activated, just to have a rough idea? Maybe a third to half. So what we are seeing is that information on these devices, it's critical, right? So it must be coded so that the device is stolen and no one can retrieve it. There is a set of tools that is available there for you to do regular scans, like single bill of materials and other Kubernetes tools to verify. However, we also see that deployment requires adding new elements, open policy agent with Aqua Security, whatever you want to use. So the whole stack should be analyzed and the information on the hard drive should be protected, right? So the devices can be, in case they're stolen, that's not going to provide any problems. Also, immutable OS, in the case of deployment across the whole estate, simplifies not only management, but also security certifications, right? So if at some point the company will be obliged to pass anything related to security, PCI DSS, doesn't matter. Having an immutable OS with a specific set of paths that's available for writing simplifies it massively, okay? Auto-healing. This is what I was talking about. So we don't have, let's imagine connectivity is intermittent, nothing is working like in a stable way. Sometimes there is a power cut, sometimes there is internet cut, sometimes there may be device has gone overheated because of the temperature on a factory floor. So would the device be able to cope, right? Would your installation be able to cope? Hardware failure. Like I mentioned, with deployment on scale, some of the devices will inevitably fail. Now, what happens if you have just one device? What happens if you have 2 devices, 3 devices? Would the cluster work? Now, I'm sure most of you are familiar with SIEM and ARMY. It's still applicable to Kubernetes. And for those of you who are not familiar, it's basically just random killing of pods, deployment, stateful sets, cables, internet connectivity, power cuts, everything. So that's still applicable. The requirement for devices is they would be able to heal themselves without any intervention because, well, we don't have any skills. Onboarding is quite important, right? So what we've seen is that a number of attempts to send devices which require some sort of configuration. Well, it's not happening, right? So sometimes we don't know the networking. Sometimes we don't know what's going to be bandwidth or location. But what we've seen is the devices have been sent. Quite often, these devices are not the center of the universe. It's not where what manufacturing exists. There will be a huge device producing something, right? Now, there won't be any attention to this device. It should just work. What we are seeing as best is that the local stuff can just plug maybe color-coded cable, plug power, and that should work. The best test we found for it is simply just give the device to someone, I don't know, in a different team, maybe who are not technical, just plug it in and see. You may be surprised, right? So we're all into this ecosystem. We all know how the system boots, we all how it works, how it gets IP addresses. Well, that's not always the reality on a manufacturing, right? So on a factory floor, there will be devices producing stuff. There will be people who could just plug the cables, but they can't do any debugging. So what we expect to happen, even if, let's say, network changes. So DHCP has been a kind of complicated scenario for Kubernetes, because Kubernetes wasn't conceived for it. However, the reality of manufacturing is that sometimes you don't control the environment, right? Sometimes you would just communicate with another company. You can't dictate network conditions. So your solution, whatever you're using, must respect those norms. So we don't expect everything to work as we dictate it. So that should be taken into accommodation. So the recommendation here is just to do a testing within local conditions before sending devices overseas, because again, it just all takes time. So what I wanted to recommend, a couple of ways, a couple of paths for you to go forward. The first one is just take a look at our project K8s, which is an open source meta operating system. Well, it's ideally made for Edge, it's open source. You can just take a look and see how it helps, right? Local AI allows you to run AI applications on the edge, which we are seeing driving more and more with various types of devices. It's also there, it's also open source. And second, and the last thing is just to talk to us. So we are just here right away. If you leave from the building from the room to the left, and we will be here the whole week for the stand N182. So I'm still having 5 minutes. I'm not sure if you have any questions, folks, but if you have any questions or if you want me to go into some details, I'd be happy to answer or provide more information. No questions? All right, well, in this case, I'm done. Thank you. Thanks, everyone, for being here. And yeah, see you.